Hello dear friends, welcome to the lecture of ordinary differential equations. In this lecture, we shall attempt some multiple choice questions on ordinary differential equations. So I have written these questions here. Suggest you to take a screenshot, attempt first yourself and then verify the answers. The first question is, in the equation a0 of x, y to nth derivative of y, this means nth derivative of y, plus a1x, n minus 1th derivative of y, and plus so on, an of x into y is equal to b of x. The point x is called singular point. So what about the condition for the point x is a singular point if the first coefficient of nth derivative of y, first term, coefficient of first term is 0. Then for that value of x, the point x is called singular point, and therefore the correct alternative is a0 of x is equal to 0. Then it is the value of x is called singular point. So this is the answer, correct alternative. The next question is a set of functions which has the property that if phi1 and phi1 comma phi2 belong to the set and c1 comma c2 are any constants, then its combination, linear combination, that is c1 phi1 plus c2 phi2 belongs to the same set, and this type of set is called, and we know this is a linear combination, and it is known as linear space. So the alternatives are linear space of functions, Banach space, uniform space of functions, Hilbert space. So it is similar to the linear, in our linear algebra also we have seen linear span of a vector space, and this the linear combination of two functions is known as linear span, and here it will be linear space. So linear space of functions is the correct alternative. Next one, the equation y double prime, that is second derivative of y, plus 1 by x first derivative of y minus 1 upon x square y is equal to 0 for x greater than 0 has a solution of the form. Now this is a homogeneous function. See, it may also be written as, if you multiply by x square throughout, then that equation can be written as x square y double prime, or second derivative of y. In the third question, the equation is x square second derivative of y, and if you multiply this by x square, we will get x into first derivative of y minus y is equal to 0. And so this is homogeneous equation, and its solution is assumed in the form of x to the power r. So thus the equation has solution of this form, x power r, where r is constant, and the remaining alternative are exponential, xr, etc. So but this is the correct alternative for the third. Now the fourth is, if phi1 up to phi n are n solutions of this equation, this is a homogeneous equation where the coefficient of first term, this is of the form a0 of x is 1. So nth derivative of y plus a1 of x, n minus 1th derivative of y, and so on, an x into y is equal to 0. On an interval I, they are linearly independent if and only if. What is the condition for that? They will be linearly independent, and the condition for that is w function. This function is known as Wronskian. So Wronskian of these functions phi1 up to phi n, that is actually a determinant. W of phi1 up to phi n is a determinant whose first row is the same functions phi1, phi2, etc. phi n. The second row is the first derivative of these functions, and the third row will be second derivative, and so on. So the last will be n minus 1th derivative of these functions. This determinant is known as Wronskian. And if this determinant, what is the condition for linearly independent? This determinant is Wronskian is 0 for all x belongs to I, the interval, or that Wronskian is not 0, or that Wronskian is 1, 2, etc. And that is the theorem or result. These solutions are linearly independent if and only if the Wronskian is non-zero. So this must not be equal to 0, and thus this is the second alternative, B. The Wronskian of the function. Again the question is on the Wronskian. Wronskian of the function or of the solutions phi 1 and phi 2. Now see, we have written the Wronskian determinant in this form, and for two functions the Wronskian will be a 2 by 2 determinant. So that will be W of phi 1 and phi 2. See, for fifth question, this is we have written for fourth. Now fifth question, W of phi 1 phi 2 is equal to, according to this, that will be phi 1 phi 2. Only two functions are there. If there are n functions, the first row will be these n functions, and second row is phi 1 dash phi 2 dash. That means derivative of phi 1 and derivative of phi 2. So what is phi 1 function here given? Phi 1 is e power 2x and phi 2 is e to the power 3x. And now what will be their derivatives? We know derivative of this e to the power 2x is twice e to the power 2x, and this will be e to the power 3x into 3, that is 3 e to the power 3x. And you see, what is the value of this? This will be 3 times e to the power 5x minus 2 times e to the power 5x. So 3 minus 2 means 1 times e to the power 5x, expansion of this determinant. So this is the answer, and that is the choice D. Two solutions of this are what? What are the two solutions? Earlier we have seen that a solution of homogeneous equation is of the form x to the power r, and therefore the solutions of this equation, which is y double prime, that is sixth, y second derivative of y minus 2 into x square, or that can also be written as x square by multiplication by x square minus 2y is equal to 0. Now we can check if y is equal to, for the first alternative, y is x square, then LHS of this equation will be, see, x square into second derivative of x square. So what is the second derivative of x square? First derivative is 2x and second derivative is 2. So x square into 2 minus 2, y is x square. So this is equal to 0. So therefore this is a solution. Y is equal to x square is a solution. And similarly we can say y is x to the power minus 1. Actually, if one solution is known, then there is a method to find another solution. But here we can check for y is x to the power minus 1. Then what will be LHS of this equation? That is x square, second derivative of this. First derivative is minus 1 upon x square, that is equal to minus x to the power minus 2, and this is y dash, and y double dash or second derivative will be minus 1 minus 2, that is 2 x to the power minus 3. So that is 2 x to the power minus 3. And next is minus 2y. So what is y? X power minus 1. So what is this value? You see, this is 2x power minus 1 minus 2x power minus 1, that is 0. And therefore these are the two solutions of this equation. We have actually obtained the solution by verification, but we may use the method to obtain the solutions. One solution is known to be x square. So this is the alternative. And this equation, 1 minus x square into second derivative of y minus 2x first derivative of y plus alpha plus 1 times y is equal to 0. This is known as, so this is known as the standard equation or differential equation, and that is known as Legendre equation. So this is the definition of Legendre's differential equation. So thus this is the correct alternative for the 7th problem. These are the next questions. First attempt yourself and then verify the answers. The 8th question is the coefficient of x power n in the nth Legendre polynomial Pn of x is. Now that is in the method of solution of Legendre's equation, and the polynomial obtained Pn of x is obtained as 2n factorial divided by 2 power n into n factorial square. So this is the correct alternative for this. So it is a part of the solution of Legendre equation. Now the second is on Legendre's polynomial integral -1 to 1 Pn square of x into dx is equal to which of these? Actually the result is of this type, integral -1 to 1 Pn of x into Pm of x into dx. This is equal to, it has two possibilities. So one, that is a 0 if n is not equal to m. This product, if n and m are different, then this integral is 0. And that is if n is equal to m, then it becomes m is n means it becomes Pn square. Then in that case it is 2 divided by 2n plus 1. That is 2 divided by 2n plus 1 if n is equal to m. So thus the correct alternative here is C. And you should remember also this, that is a Pn into Pm integral. It is integrated between -1 to +1 with respect to x. Then the integral value is 0 if n is not equal to m. And if n is equal to m, it is 2 divided by 2n plus 1. So this is the answer. The regular singular point of the equation for this equation. You see, we earlier seen what is the singular point. If the coefficient of the first term in the differential equation is 0, that value of x gives the singular points. And here what is the coefficient of y, second derivative of y, that is 1 minus x square, and we have to equate that to 0. 1 minus x square is equal to 0, or that means x square is equal to 1, or that means x is equal to plus or minus 1. So in this way it is simple that the regular singular points are plus or minus 1. And the next is dependent on the method of solution. This is a solution, or which is a function of 0 order, that is summation m takes value 0 to infinity -1 power m divided by m factorial whole square into x by 2 raised to 2m. This is known as which function of 0th order? Either Legendre, Hermite, Chebyshev or Bessel. So actually this is j0 x. This function is denoted by j0 of x. The question may also be asked why this is denoted by which notation? That is j0 x, and it is known as Bessel's function. Bessel's function of 0 order. So this is the alternative. The next is the equation. See, the equation x square second derivative of y plus a into x first derivative of y plus by is equal to 0 is known as, that is the definition of differential equation, standard differential equation, and this is second order Euler equation. So this is the correct alternative. And now this is for an example, x square y double dash plus 2x into y dash minus 6y is equal to 0. So actually this will be Euler equation. You see, it is of the same type. A is there, here it is 2, b is minus 6. And to solve Euler's equation of second order, we can write the characteristic polynomial. For the Euler equation, for this equation, the characteristic polynomial is given by, characteristic polynomial is r minus 1 plus ar plus b is equal to 0. Now what is the value of a? We can compare. A is here 2 and b is minus 6. So therefore that will be r into r minus 1 plus 2r minus 6 is equal to 0, or that gives, after simplification, r square minus r plus 2r is plus r minus 6 is 0, or this can be factored as r plus 3 r minus 2 is equal to 0, or that gives the value of r as minus 3 and plus 2. And if these are the values of r, then the solutions are x to the power that is a c1. So separate solution, or the solution is, combination will be the solution. Solution is y is equal to c1 x power minus 3 plus c2 x power 2. So this will be the solution corresponding to these roots of the characteristic polynomial. And you see which will be the choice here. c1 x power minus 3 plus c2 x to the power 2. And this is the correct choice. So next is 14th is, for x greater than 0, the function phi1 of x power r and phi2 x power r log x are the solutions of which equation? So actually these are solutions of the Euler equation when the roots are repeated. You see, we have written here, if r is r has these roots, or the characteristic polynomial has these roots, and that means r has these values, then we write x power r as the solution. Two solutions will be x power minus 3 and x power 2, and general solution will be combination of this. But if the roots are repeated, and then if r is repeated 2 times, then the solutions are to be written as x power r and x power r log x. So if the solutions are repeated, but these are the solutions of Euler equation. So this D is the correct alternative for this. Now these are some next questions. 15th question is, the following x cube third derivative of y plus 2x square second derivative of y plus y dash plus 6xy is equal to 0, where y at 0 is 1, y dash at 0 is 0, y double dash at 0 is 1. This is known as which type of problem? And there are two types of problems, initial value problem and boundary value problem, and some problems may be of mix, that is both type, the initial and boundary value problem. Now the difference is, for initial value problem, the values at initial point, some initial point or fixed point are given, and for boundary value, these are the values at the boundaries, means different points are given. But for this problem, this is the equation, and where y, the value of y at 0 is given, the value of first derivative of y at 0 is given, and the value of second derivative of y at 0 is given. That means this point is fixed and that is the initial point. So therefore if these are not different points, and for which the value of the function, its derivatives are given, then that problem is known as initial value problem. So this is initial value problem. The solutions of this equation, the solutions, phi1 which is x square, phi2 which is 1 by x of this equation, these are the solutions of the equation that is given, and these are what type of solutions that we have to decide, linearly dependent or independent, or both or none of these. And for this purpose we have a condition for linearly independent solutions. The Wronskian of the solutions must not be 0, or that is not equal to 0. And we have seen earlier also this type of question, and here what will be W of phi1 phi2, and that is first row will be phi1 phi2, second is the derivative of this, and that is x square, first row of the determinant x square 1 by x, second row the derivative of x square is 2x, the derivative of 1 by x is minus 1 upon x square, and see its value is, this is minus 1 minus of this is 2, and which is minus 3, this is not equal to 0, therefore these are linearly independent. these solutions are linearly independent. This is the condition. Wronskian must not be 0, and thus the linearly independent is the correct alternative. Next, the solutions of this equation are, what are the solutions of this equation? Now see, this is Euler equation, and we know how to write the characteristic polynomial for that type of equation, and for that is, it is r into r minus 1 for 17th problem. Characteristic polynomial is r into r minus 1 plus ar plus b is equal to 0. We have seen this type of question earlier also, and here it is r minus 1 plus, what is a? A is this coefficient of the second term, and that is 1 here. A is 1. So 1 into r plus b. B is the coefficient of y. This here is the value of a, x, y dash. A is 1 and b is 4. So that is 0. Or this will be r square minus r plus 4 means r square plus 4 is equal to 0. Or that is r square is equal to negative of 4. Or this gives, or this implies r is equal to, take the square root, and here it is negative, and square root of minus 1 is I, so that is plus minus 2i. This is the value of r, and therefore the solution is x power r, and that is x to the power 2i and x to the power negative 2i is the solution. So this is the choice C. Correct alternative is C. The next one is, if psi p is particular solution of this equation, that is a non-homogeneous equation, L of y nth degree equation, nth order equation, it is non-homogeneous nth order equation, and phi 1, phi 2, phi n are linearly independent solutions of this equation, L of y is equal to 0, homogeneous equation, then every solution psi of L of y is equal to, actually this should be b of x, L of y equal to b of x. Solution of this equation we want, and this is the same method that we know. We first solve this equation, homogeneous equation, L of y is equal to 0, and obtain complementary function, and then we find the particular integral, which is psi of p, and the general solution or the solution of the original equation will be the complementary function plus the particular integral. Now the particular integral is psi p, and what will be the complementary function? If phi 1, phi 2, phi n are the linearly independent solutions of homogeneous equation, then complementary function will be combination of this, that is c1 phi 1 plus c2 phi 2 up to cn phi n, and sum of this with psi p is the solution required, or general solution of the equation L of y is equal to b of x, and thus see, the first one is the correct alternative. Psi p particular integral, so this is particular integral and this is the complementary function. And the next is Wronskian of the solution of these solutions. It is similar to this. So for 19th, the Wronskian of two solutions, that is first is function cos x sin x, and second row is their derivatives. Derivative of cos x is negative sin x and sin x is cos x. So what is the value of this determinant? Cos square x minus of minus sin square x means cos square x plus sin square x, which is 1 and not 0. And if the Wronskian is not 0, or that is the value is asked, the Wronskian of solution is 1, and these are independent, but the value is asked and that is 1. So therefore A is the correct alternative. And the next question is the Legendre polynomial of degree 1 is. So that is a standard result. The Legendre polynomial of degree 0 is 1, and we denote the Legendre polynomial by Pn of x. So we have P naught of x is 1 and P1 of x is x. So you should note this, and the degree 1 Legendre polynomial is x. That is the correct alternative. So thus in this lecture we have solved some of the, not all, but some of the multiple choice questions on ordinary differential equations. Thank you.